As I'd mentioned before, that initial wizard only gets you part of the way configured. For us to get any further, we've got to go through a series of tabs here that are under the properties of our WDS server to configure it so that it behaves in the way that we're looking for. So let me right-click here on our server, and you can see this long list of tabs here that I want to step through one at a time, just to give you kind of a quick idea of the purpose for each of these tabs. The first of which is our Pixie Response tab, which allows us to identify what the Pixie Response policy will be for this environment. I'm going to choose again the checkbox here to require administrator approval for any of those unknown computers that are coming in, and you'll see here in just a minute as to why I'm configuring this in the way that I am. Also, if I have a couple of different Pixie servers out there, I can choose to delay the Pixie response so that clients would actually have the abilities to get their Pixie response from some other server first. In most cases, you typically only have a single Pixie server in an environment, so the configuration of a Pixie response delay is not something you would necessarily do, except in the occasional use case of perhaps load balancing or a failover situation. Over here in ADDS is where we can configure the client naming policy, or essentially how any unknown client computers are going to be named. Here in just a minute, I will show you a much better way in which you can configure this client naming policy, as opposed to just creating machines with a random computer name. Down here under computer account location is where we can identify where we want to create the computer accounts for the machines that we're deploying. That will be in either the same domain as our WDS server. That can be in the same domain as the user, the same organizational unit, or I can choose a specific organizational unit here in my domain. So, for example, the company computers organizational unit. This gives me the flexibility of ensuring that any new computers coming online are going to end up in that correct OU so they get group policy. Here under boot is where we can identify some of the boot characteristics. This is a very important tab because it's here where you can kind of inadvertently create some pretty big headache for yourself if you're not careful. Remember, when a machine boots, there is a boot order that is configured in the BIOS. Now that boot order for a lot of computers will default to a Pixie boot being the very first item in the BIOS. After that typically is the CD-ROM, and after that being the operating system on the hard disk. Well, if you have that Pixie boot as being the first boot, and you should choose, for example, this item here to always continue the Pixie boot, you could potentially create a situation where every time a user attempts to boot their machine, they'll get a new operating system. That's probably not something you're looking for. So in many situations, and in fact it's the default, that the user is required to press the F12 key to continue the Pixie boot. Now this is the case for known clients. These are clients that are already in the Active Directory database. Down here for unknown clients, you may actually want to always continue the Pixie boot because this allows you to just simply plug in the machine and turn it on, and it will automatically get an operating system deployed to it. Again, this is for unknown clients. So once that client's in Active Directory, well, then it'll shift up here to become a known client, and you'll have to hit that F12 key. You have down here also the ability to choose a default boot image if you want. Now for any of these different architectures, you can either allow WDS to identify what the boot image should be. It generally does a pretty good job of deploying the correct boot image. But in certain circumstances, you may have multiple different boot images that have slightly different configurations. That level of customization goes far beyond what we can talk about here in this module. But if that's the case, you may want to come down here and then define what your default boot image should be for the different operating system architecture, like in this case, the Microsoft Windows Setup x64 boot image. I'll choose this just so that we can just see that in fact this is one way that we can define what that correct WIM file should be. But for the most part, unless you go about customizing your WinPE environment, you won't find yourself doing anything here with these default boot images. Down here under Client is where we can identify some additional configurations that will further configure the machine as we go through this OS deployment. Now, one of which here is this unattend file. And these unattend files are a really slick way for you to take a machine that would normally be just a regular machine right out of the box and provide a little additional configuration at the moment it's deployed. The creation of these unattend files is something that happens using a completely different tool called the Windows System Image Manager, which is part of the Automated Deployment Toolkit you can download from Microsoft. The only thing I want to show you here is that I've actually installed the Automated Deployment Toolkit, or the Windows ADK, onto this machine so that I could get access to the Windows System Image Manager. WSIM is a very complex tool, and we don't have a lot of time here to go through the detailed configuration and use of WSIM, but what this tool allows you to do is to identify the list of questions you're interested in answering as part of this unattend.xml file, and then over here in the middle to provide the answers and then the properties associated with those answers for those different questions. These can be questions like, which domain would you like to be a part of? These can be questions like, what is the name of the administrator account? What's the initial password? Do you want the user to have to see that hi screen that appears when they first log in? And a variety of other things that are baked in to that install.wim file. Now, here at Pluralsight, we've got a variety of different deployment courses that will go into greater detail on WSIM, but for the purposes of this exam, I would be aware that the WSIM tool exists, that it's a part of the Windows ADK, or the Automated Deployment Toolkit, and it is this tool that allows you to create these unattended installation files to bring those machines a little further along every time you go through an OS deployment. Should you do that, you would click here to enable unattended installation, define your architecture, and then locate the XML file that you would choose here. So you'd essentially spit out an XML file out of WSIM and then connect to it here. We're not going to do that here for our purposes. We're also going to ensure that our clients are joined into the domain, and we're not going to turn on any client logging here. This bottom one down here provides you the abilities to identify why you're seeing some error messages as you're going through the deployment process. This can be, in many ways, your only way of figuring out why things are broken once you start going into production. Down here under DHCP is perhaps one of the most confusing tabs in all of Windows deployment services. And it has to do with a very long if-then statement that Microsoft has implemented and never corrected, never made easier to understand, that corresponds to how WDS interacts with your DHCP server. Let me just show you up here that the top paragraph that says if DHCP is running on this server, you need to check both of the following checkboxes and then use DHCP tools to add the appropriate Pixie options to the scopes. Now, I'll show you how to do that here in just a second, but remember, if it's on the same server as DHCP, you need to check these boxes. If you're using a non-Microsoft DHCP server, then you need to check the top box and make some other configurations. So we don't have to check the boxes because DHCP is on our domain controller, a completely different machine. But I want to highlight this because this tab and the DHCP scope option configurations are easily the most confusing part of dealing with WDS. Let's flip back over here to Multicast. We'll come back to DHCP here in just a second. As I mentioned, many environments, the network engineers of many environments don't really dig Multicast. It is a very noisy protocol. The whole point behind Multicast is that you spray out the information you want on the network, and whoever needs to get it will receive it all at the same time. Well, the biggest problem with Multicast is that the process of spraying that information out on the network really can congest the network at the same time. So a lot of network engineers really don't like having Multicast passing around on their network. WDS, however, uses Multicast in the situation where you have multiple machines getting an operating system deployment at the same time. So this tab provides you the abilities to define a specific set of multicast addresses or also to obtain those IP addresses from DHCP. Most often you find the bottom checkbox here that is checked, and then these are just configured with the defaults. Now, one of the other big issues with using multicast is that a multicast is a one-to-many transfer. And so each machine that is participating in that multicast transmission needs to keep up with all the other machines. What this means is that the slowest of those machines really drives the performance of that multicast transmission. Here within WDS, you have the abilities to then kind of kick off the island, the slowest of the clients, if you want, by choosing any of the three bottom items down here. If you choose the default here, the multicast session will always default to the slowest client. Or you can choose to separate clients into 2 or 3 sessions or disconnect clients that just can't keep up. This can come in handy when you have extremely large deployments. So you're pushing an OS deployment to 20 or 30 machines all at once. This can help split things up into your slow and your fast, or your slow, medium, and fast deployments, so that at least your fast machines can get done a little bit quicker. Over here under Advanced is where we can configure some additional configurations. Number one is whether or not we want WDS to dynamically determine which domain controller it should use. That will most generally be the closest domain controller. Or if for some reason it's not finding the right domain controller, you can specify one down here with the bottom checkbox. This is less important down here under the bottom, where we identify the authorization, the WDS authorization over at DHCP, so that we can complete the connection between our DHCP server and our WDS server. Notice that by default, we are not authorizing this WDS server in DHCP, but we want to click this box down here at the bottom to authorize WDS. This will be necessary so that WDS and DHCP can handshake when it comes time to hand off an incoming client over here for an OS deployment. We have two final tabs to go through, the first of which is our network tab here, where we can identify what our UDP port policy will be. UDP actually can be used to increase the throughput for deploying these OS images, and then we can choose essentially what ports we're going to be using for our UDP port policy here. And then over here for TFTP, it's the TFTP protocol that is used to transfer that initial boot over to our awaiting clients. And TFTP just has a couple different configurations here for the block size and the window extension or variable window extension here. For the most part, you just leave these as the defaults. So this is essentially the configuration of our WDS server. With these configurations now in place, we can now spend some time talking about the images themselves.